Welcome to this e-learning session on quantitative research methods in social sciences. I'm Dr. Haihu Guo from the Department of Society and Health, Faculty of Social Sciences and Humanities at Mahidol University. Today we will focus on measurement design, an important concept in quantitative research. In this session, we will explore three key topics. First, we will cover scales of measurement to understand how variables are categorized and interpreted. Then we will look at two main types of measurement instruments used in social sciences: structured questionnaires and standardized scales or indexes. Finally, we will go through the steps instrument development, focusing on how to ensure reliability and validity. Before we dive into measurement steps, let's ask why it matters. Measurement links abstract ideas to observable data. It helps us collect accurate information and apply the right analysis. Without good measurement, our research findings lose meaning. Measurement skills determine how we classify and interpret our data. Choosing the correct skill is important because it affects the types of statistical tests we can apply. There are four main types of skills: nominal, ordinal, interval, and ratio. Each has unique properties and is used for different kinds of data. The nominal skill is the simplest form of measurement. It categorizes data without any sense of order or rank. Each value represents a label or a category. For example, assigning 1 for male and 2 for female doesn't mean that 2 is greater than 1. This type of skill is used for variables like gender, marital status, or blood type. The only measure of central tendency applicable is the mode. The ordinal skill classifies data into categories that have a meaningful order. However, the interval between the values are not known or consistent. For instance, satisfaction levels from dissatisfied to satisfied, or educational levels such as bachelor's, master's, and doctoral degrees. We can see one rank is higher than another, but we can't determine how much higher. Median and mode can be used, and this skill is analyzed with non-parametric tests. Interval skills at equal distances between values. Unlike ordinal skills, the difference between two values is meaningful. However, they do not have a true zero. Examples include IQ scores or temperatures. Because the zero doesn't represent the absence of the trait, we cannot make ratio comparisons. We can use mean, median, and mode, and apply parametric tests. Ratio skills are the highest level of measurement. They include other properties of interval skills, but with an absolute 0 point. This makes it possible to make ratio statements like twice as much. Examples include height, age, and weight. All statistical methods can be used on ratio data. Let's now compare the four skills in one overview. Nominal skills label data without order. Ordinal skills add ranking but not consistent intervals. Interval skills include equal distances but no true zero. Ratio skills combine all features and include a meaningful zero. Understanding the differences helps ensure correct data analysis and interpretation. There are many ways to collect quantitative data. In this session, we will focus on two core tools: structured questionnaires and standardized scales or indices. Both are essential for getting valid, objective, and numerical data in social science research. The key is to select a tool that matches your construct and your research objectives. Structured questionnaires consist of pre-designed, close-ended questions aimed at gathering quantifiable data. These are highly consistent across participants and commonly used like lecture skills, multi-choice, and yes-no formats. They are used to measure things like behaviors, attitudes, or demographic characteristics in large populations. Let's look at some example items. For instance, I feel stressed at work rated on a 5-point Likert scale, from strongly disagree to strongly agree. Another example is asking about sleep duration, with choices like less than 5 hours, 5 to 6 hours, and so on. These questionnaires are easy to administer, simple to analyze, and ideal for large-scale studies involving descriptive and inferential statistical analysis. Standardized scales and indices are used to measure abstract concepts or latent constructs like anxiety, stress, or self-esteem. These are pre-tested instruments that have undergone psychometric validation. They provide reliable and consistent data across various populations and studies. Some widely used skills include the Rosenberg Self-Esteem Scale, the Beck Depression Inventory, and the Perceived Stress Scale. These instruments are reliable and valid, allowing cross-section comparison and advanced statistical analysis like SEM, structural equation modeling, or CFA, confirmatory factor analysis. Now let's walk through the process of instrument development. The goal is to create a tool that is reliable, valid, and appropriate for the research context. We start by defining our construct, then develop and refine items, and finally assess reliability and validity. This ensures the tool is both theoretically grounded and statistically grounded. The first section involves defining the construct. This means using literature to clarify what concept we want to measure, such as stress or self-esteem. Next, we generate items that reflect various aspects of that construct. Each item should be clear, specific, and not double-barreled. Then we conduct content validation to ask experts to review each term. We can quantify this using the CVI. Next, we choose a response format. Lecture skills are most common in social science. These typically range from 1 to 5 or 1 to 7, indicating levels of agreement or frequency. An example might be, I feel overwhelmed by my workload, with responses from strongly disagree to strongly agree. Lecture skills are easy to use, and their data are suitable for many types of statistical analysis. Now let's talk about validity. Content validity ensures that the instrument items reflect the construct, often based on expert judgment. Construct validity is assessed using statistical methods like exploratory or confirmatory factor analysis. Criterion validity compares the instrument's results with an external gold standard measure, either at the same time or later. Content validity checks whether all items truly reflect the concept we want to measure. First, we create an item pool based on theory and past studies. Then we ask 3 to 5 experts To review each item, they rate the items for relevance, usually on a 1 to 4 scale. We calculate the ICVI, which is the percentage of experts who rate an item as 3 or 4. An ICVI of 0.78 or above is considered acceptable. The SCVI is the average across all items. If items score low, we revise or remove them to improve quality. This method is widely used, especially in health and social science research. Reliability tells us whether our instrument produces consistent results. Internal consistency is checked using ChromeBus Alpha, with values above 0.7 considered acceptable. Test-retest reliability means that scores should be stable over time. Inter-rater reliability is useful when multiple raters or observers are involved. A reliable instrument enhances the credibility of our research findings. Let's wrap up with a practical checklist. Start by clearly defining your construct, what exactly you want to measure. Choose the right scale based on how your data behaves. Then decide whether to use a structured questionnaire or standardized scale. Always validate your items, especially for content and construct relevance. Check reliability to ensure your tool is consistent. And don't forget to do pilot test before launching your full study. Following these steps will lead to more valid, reliable, and trustworthy research findings. Thank you for your attention. In this session, we have learned the important part of measurement design. See you in the next session.